Hello guys, welcome back to my video, and today we are going to start with a new topic, that is quadrilaterals class 9th. So let's begin. Now we have some general terms. Let's discuss them. Now the first one is vertices. Vertices. Now vertices is really less used, but it is important. Now the points A, B, C, D are called vertices. Okay. Example, here you have a small diagram. Now let's name it A, B, C and D. Now A, B, C, D, they are called the vertices. Okay. Now the second is sides, and I'm sure you guys know it already, but still I'm going to tell you. The line segment, the line segment AB, BC, DC and DA are called vertices. Sorry, they are called sides. Okay. Now third, diagonals. Diagonals, the line segment, the line segment AC and BD are called diagonals. Let's explain this with the help of an diagram. So here we have, let's say, a really long, lengthy rhombus. Let's name it P, Q, R, and S. Let's do it ABC, because in the statement I have written AB. So A, B, C, D. So when you join A with C and B with D, the line segment formed is called diagonal. Okay. Now the fourth is adjacent sides. Two sides of a quadrilateral, sorry, the spelling is wrong, but I am sure you know, having a common end point are called its adjacent sides. Okay. Now fifth, opposite sides. Two sides of a quadrilateral having no common endpoint are called its opposite sides. Now that's all you guys need to know. So let's begin with our first theorem or property, that is angle sum property of triangle. Angle sum property of triangle. Now I will explain this with the help of a diagram. So here we have drawn a quadrilateral. Let's name it A, B, C and D. Now let's draw a diagonal that is AC. Okay. Now at first, what can you guys see? A quadrilateral with a diagonal, right? Only one diagonal? Yes. Now one thing that you guys need to know is that the quadrilateral, inside of it, it is forming two triangles that have the same sum of angles. So now let's name them. This is angle 1, this is angle 2, angle 3, angle 4, angle 5 and angle 6. So let's name this triangle 1 and this one as 2. Or you can also name it triangle ABC, your choice. So triangle ABC, this triangle ABC. Now angle 1 plus angle 2 plus angle 3 is equal to 180 degree. The sum of all angles of a triangle is equal to 180 degree. Now the second triangle, triangle ADC, angle 4 plus angle 5 plus angle 6 is also equal to 180 degree. Now when we add these two angles, since they are forming inside the same quadrilateral, right? It's not like one triangle is in another quadrilateral and the other in some other. Yeah. So we are going to add the angles. So they are going to result in 360 degree. So what do we get from this? That the sum of all the angles of a quadrilateral, short form I have written quad, the sum of all the angles of a quadrilateral is equal to 360 degree. Okay. Now let's move to theorems. Okay, theorem is the most important one in this chapter. Okay. Also angle sum property is even important. I mean equally important, theorems and angle sum property. Now let's begin with theorem 1. So what does the theorem 1 state? Let's see. A diagonal of a parallelogram divides it into two congruent triangles. Okay. Now the one that I explained you here, triangle ABCD, I mean not a triangle, quadrilateral ABCD. Now the diagonal forms congruent triangles. Okay. Whenever you divide a quadrilateral or a parallelogram into two equal halves or two equal triangles, those both triangles are always congruent to each other. And I have, I think, already explained you what is the meaning of congruent, but if you don't know, I will do it again. Congruent. The meaning of congruent is the figure must superimpose on the other figure. Okay. Now suppose if we have two triangles over here, let's name them A, B, C, P, Q, R. Although they don't look congruent when you look at the diagram, but I am just explaining you for example. Okay. Now if we keep this triangle ABC onto triangle PQR. They are going to superimpose. Superimpose, the meaning of superimpose is when you keep one thing over the another. There is no space left. Okay, there is nothing like the other triangle is bigger or smaller than the other. They are equal in length, size and shape. That is the meaning of superimpose. And the congruency is also related to that only. Now let's begin with theorem 2. 2. In a parallelogram, in a parallelogram, opposite sides are equal. Okay, let's draw a diagram. Suppose we have this one. Yes, let's name it A, B, C and D. AB, side AB is going to be equal to side DC, and side AD is going to be equal to side BC. So you can write DC is equal to AB and CB is equal to AD. That is our theorem 2. Now theorem 3. Theorem 3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Or you can also write this spelling as double LGM. Okay, but don't write this in exam. The teacher will definitely cut your marks. Now let's read this statement again. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Okay, just this theorem is related to theorem number 2 as well. If the sides are equal, then it is, the opposite sides are equal, then only it is a parallelogram. That's it, nothing more. Now theorem 4. What is theorem 4? Let's see. In a parallelogram, opposite angles are equal. Suppose here we draw a shape that is a parallelogram, right? Let's name it A, B, C, D, and angle 1, angle 2, angle 3, angle 4, right? Now angle 1 is going to be equal to angle 3. Angle 2 is going to be equal to angle 4, right? As simple as that. Now let's look at the next theorem, that is theorem number 5. Theorem 5. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Okay, let's read this statement again. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Done. Easy. Theorem 6. The diagonals of a parallelogram bisect each other. Okay, that's it. I thought there was more. Now let's draw a parallelogram. Now name it A, B, C and D. Now if we draw a line from A to C, we have a diagonal, but it is only one. Now let's draw another diagonal, that is B to D, like this. Okay. Now what can you see? We can see that this O point is the intersection point of those two diagonals. Hence this statement is proved. The diagonals of a parallelogram bisect each other. Done. These theorems are really easy. Now let's look at theorem number 7. Theorem 7. I think in this chapter you guys only have 10 theorems. Let's see. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Let's draw this diagram. Oh, I'm drawing really lengthy diagrams today. Let's name it A, B, C, D, A to C, A to C. This is a diagram. B to D. This is another diagram. Sorry, diagonal. Now, if you see angle 1 and here let's suppose angle 2. Angle 2. Angle 1 and angle 2 are equal. Now you must be thinking, how are angle 1 and angle 2 equal? Now you can apply the property of alternate interior angles. Or I think in theorem 5 or 3, you have a property that is called the opposite angles are equal. Since so their halves will be also equal, right? So angle 3 and angle 4 over here are equal. That is it. That is theorem number 7. Now theorem 8. A quadrilateral a quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. Let's read this statement again. A quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. Let's draw a diagram. Now let's name it A, B, C and D. A quadrilateral is a parallelogram if opposite sides are equal and parallel. Now if we take angle 1 and angle 2, both of them are equal. And what do you think? What are they forming? I will show you. This diagonal and this side, they form a Z. Okay, so if these two angles are equal, then AB and DC equal, because they form a Z like this. So Z, the sides will be equal if the angles are equal. Let's begin theorem 9. Now theorem 9 and theorem 10 are really important ones. So stay focused. Now what does the theorem say? Oh, actually I forgot. Theorem 9 is also called the midpoint theorem. The midpoint theorem. Now you guys must be wondering, why? Why is it called midpoint theorem? So focus, okay, I will explain you. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay, let's draw a diagram of a triangle. Now let's draw midpoint. I think you guys remember what is a midpoint. If you don't, I will tell you. Midpoint is a point on a triangle or any kind of figure that divides a side into two equal halves. That means this side is equal to this side, right? That is called a midpoint. So here we have drawn the midpoint like this, and here another one. Let's name them D and E, and also let's name the triangle. Okay. Now if we join these midpoints like this, now what can you guys observe? There DE is parallel to AB, just like a parallelogram, just like a trapezium, right? If we draw a trapezium like this, here you go, this side is parallel to this side, not equal but they are parallel, okay, parallel to this side. Now DE is parallel to BC, right? Now suppose if we want to find what is the length of DE, okay, if you want to find D, what is the length of D? You don't know, okay, it's in between. So here is the formula. DE is equal to half into BC. This is a golden formula, and I think the first formula new to you, so make sure to remember it. If you want to find the midpoint, the parallel side that you have just created, that is DE, then you guys need to apply this formula. Let's begin theorem 10. Theorem 10. Now theorem 10 is actually really simple, but the definition that these guys have given is lengthy. And also, just like theorem 9, it has another name, that is converse of midpoint theorem. The line segment drawn through the midpoint of one side of one side of a triangle parallel parallel to another side bisects the third side. Right. Let's draw a diagram. Let's draw our midpoints, that is D and E. Now let's read this theorem again. The line segment drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Now let's name it ABC. We have a midpoint that is on AC. Now a line is extended from the midpoint D and it reaches or touches BC. So there is another midpoint formed on the third side. So this is first side, second side and third side on the third side. Now the property of midpoint, we know that whenever there is a midpoint on any line or any line segment, it always divides the line into two equal halves. Since the midpoint of AC touches BC, so BC is also divided into two equal halves. That is what is written in this definition, but it is complicated. And now we have completed this chapter, quadrilaterals. I hope you understood everything, and if you have any doubts, please comment. And thank you for watching. Please subscribe my channel.